So let's take a look at this, 3.6, the zeros of quadratic functions. I actually mentioned this in the last lesson, but quadratic functions can have 2, 1, or 0 solutions, or real solutions. Draw a diagram below of what each scenario would look like. So let's take a look at this. Let's just take a look at, I will draw both, opening up and down. If you had 2 solutions for a parabola, that means opening up, you'd have a vertex that's down here somewhere, and you'd open up. In this case, you would have 2 solutions, one there and one there, the 2 x-intercepts. Obviously, the same argument can be made if you had a parabola that opened down, and that would mean that the vertex is up here and it opens down. You'd have a solution there and there, let's say. Okay, so 2 solutions. You have either the vertex down here opening up or the vertex up there opening down. You'll have 2 solutions. You may have no solutions, and again, you may have a parabola that has a vertex up here, but instead of opening down, it opens up. It will never touch the x-axis, so therefore there are no solutions. Or you may have a vertex that's down here and the parabola opens down, and therefore it will never cross the x-axis, so there are no solutions again. Or the last case scenario, you may have a vertex that is right on the x-axis and it opens up. Therefore, it only crosses once. And there's only one solution. The solution is the vertex. Or you may have the vertex right on the x-axis and it opens down. Again, only one solution, only crosses once, and the solution is the vertex. So again, you may have 2 solutions, 1 solution, or no solutions. Okay? And we also spoke about looking at what's underneath the square root sign of the quadratic formula from last section there. And I had mentioned that if it's a positive number underneath the square root sign, you always end up with 2 solutions. Remember, our 2 examples, underneath the square root sign, you had a 64. And you ended up with 2 solutions. And there were 2 nice solutions you could have actually factored. And then we ended up with another positive number, it was 24. You still ended up with 2 solutions, but these ones were nice solutions. These ones were decimal solutions. They weren't nice because you can't take the square root of 24. You got to break that down. Then we looked at what happens if you have a 0 under the square root sign. And when you had the 0 under the square root sign, plus or minus the 0, you only ended up with 1 solution if you take a look at my last lesson. Because it doesn't matter if you add 0, subtract 0, you're only going to have one, it's going to be the exact same number. And then, when will you have no solution? If underneath the square root sign we had done -9, if you ended up with a -9 under the square root sign, you can't take the square root of a negative. And so if in the quadratic formula you can't take the square root of the negative, you can't do it. So there's no solution, it never crosses. Now, it's very important to understand that the numbers underneath the square root signs in the quadratic formula are called discriminants. Okay? It is called the discriminant. And you can basically use the discriminant to determine how many solutions a quadratic equation will have, whether it'll have 2, none, or 1. Basically, if the number underneath the square root sign is a positive number, you'll have 2 solutions. If the number under the square root sign is negative, no solutions. If the number under the square root sign is 0, 1 solution. I'm no longer going to say the number underneath the square root sign of the quadratic formula. I am now going to say discriminant. Discriminant is another word for saying the number underneath the square root sign of the quadratic formula. It's just a lot easier saying one word. So, if I take a look at what I wrote down here, it says there is a way to determine the number of solutions. Now, it's not going to tell you what the solutions are, but the number of solutions, how many, for any quadratic equation using just a portion of the quadratic formula. And that portion of the quadratic formula, what's important about it to determine how many, is just the square root sign or the discriminant. So here's the quadratic formula. The discriminant is the stuff underneath the radical sign. So just this stuff. That's the stuff that's underneath the square root sign. If the number under the square root sign, if that discriminant is a positive number, so if it is any number bigger than 0, there are 2 solutions, or 2 real roots. If the number under the square root sign is exactly 0, there's only one solution, or one double root. If the number underneath the square root sign, if that discriminant is negative, then there are no real roots. Okay, so it'll never cross the x-axis. Okay? So this section here deals with not finding out what the solutions are, but rather finding out how many solutions there are. So example 1, it says, use the discriminant to determine the number of roots, or x-intercepts, of each quadratic equation. So this one here, I just want to know how many, the number of. It doesn't ask us for what it is particularly, just how many times it's going to cross the x-axis. If I take a look at this, my a value is 3, my b value is 2, and my c value is 15. So using the discriminant, which is negative b squared minus 4ac, if I figure out this using these numbers here, this is going to be 2 squared minus 4 times a, which is 3, times c, which is 15. So I'm going to end up with 2 squared, which is 4, minus. Now when I do this, 4 times 15 is 60, times 3 is 180. So it's going to end up being 4 minus 180. So this is going to be negative 176. Now, since the discriminant is a negative number, there are no solutions. Because underneath the square root sign is a negative number, you're not going to be able to perform the math there, so it's impossible, no solutions. What does that mean? That means this thing opens up and the vertex is above the x-axis. It's never going to cross the x-axis. Okay? So that's what that one means there. This one here, if I take a look at the second one, B, again, I'm going to just write down that A is 2, B is negative 5, and C is negative 1. And again, it's asking me for how many roots, how many solutions. So all I have to do is look at the discriminant, not the whole thing. So B, which is negative 5 all squared, minus 4 times A, which is 2, times C, which is negative 1. If I continue this, negative 5 squared is 25, and negative 4 times 2 times negative 1 is positive 8. So 25 plus 8 is 33. So what does that mean? If the discriminant is any number above 0, a positive number, there are 2 solutions, or 2 real roots. Okay? And you can also tell me that the roots are going to be not nice roots, because you can't take the square root of 33. Underneath that square root sign is going to be a 33. They're going to be some ugly numbers. And then the last one here, if I take a look at this, again, how many solutions? So I just look at the discriminant. The a value is 1, the b value is negative 30, and the c value is 225. So looking at the discriminant of this thing, b squared, I don't know what happened there, b squared minus 4ac, if I take a look at this, b is negative 30 all squared, minus 4 times a is 1 times c is 225. Negative 30 all squared is 900, and negative 4 times 1 times 225 is 900. I get 900 minus 900, which is 0. So, if underneath the square root sign of the quadratic formula, or if the discriminant is 0, there is only one solution. I was going to put one real root, which is the exact same thing, or one double root, same thing, but there's only one solution. Okay? And the solution, obviously, in order to have one solution, means that the vertex is right on the x-axis, and it opens up because the x squared is positive. Okay? So this is another way to determine if something has one solution, no solutions, or 2 solutions. Now, the last question here, it says finding the discriminant is only necessary if the equation is given in standard form. Okay, if it's in standard form, that's the only time it's necessary. If the equation is given in vertex form, you can use common sense to figure out how many solutions there are. Right? You don't have to look at discriminants. You can only look at discriminants or quadratic formula when it is in standard form. No need to put this into standard form. We can use common sense. Determine the number of roots of each of the following quadratic equations. So if I take a look at this, how many roots does this have? Well, all I have to do is kind of just draw this thing. Okay? And it's not graph it necessarily and actually find the x-intercept. It's just asking us how many, the number of roots. Okay? So how many times does it cross the x-axis? I just need a basic sketch. The vertex of this thing is 4, 9. 4, 9 is somewhere here. 4, 9, right there. This thing opens down because the a value is negative. So if it opens down, it doesn't matter where it crosses the x-axis, but there are going to be two solutions because the vertex is above the x-axis and it opens down. It's going to cross twice. So right away I know that. Okay? This one here, same thing. If I take a look at this, common sense, it's in vertex form. If it's in vertex form, that's common sense. I don't need to look at, the discriminant. If I take a look at this, the vertex of this thing is negative 5, 1. Negative 5 is somewhere here, and 1 is here. So negative 5, 1, right there. And this thing opens up because the a value is positive 3. So if it opens up, it looks like this. So if the vertex is above the x-axis and it opens up, there are clearly no solutions because it doesn't touch the x-axis. Remember, solutions, roots, x-intercepts, those zeros, those all mean the same thing, x-intercepts. Okay? So this one does not touch the x-axis, and that is by using common sense. Okay? And so during your homework, it's going to ask you a whole bunch of things. Maybe it asks you about common sense. Maybe it asks you about finding the discriminant. Some of the questions are going to get over the top, and I will make one up. And it may ask you to find the k value that makes the following have only one solution. Okay? So find the k value that makes the following have only one solution. And the equation of the following may look like this. 0 equals, or whatever. So 0 equals 4x squared plus kx minus 7. Okay? So it says find the k value that makes the following only have one solution. Well, if I take a look at this, I have to find what value k should be so that this only has one solution. Well, in order to have one solution, you have to remember that the discriminant has to equal 0. Okay, so the discriminant of this parabola has to equal 0. If you only want one solution, the discriminant equals 0. And of course, the a value here is 4, and the b value is k, and the c value is negative 7. So all I have to do is plug in b is k, so this is k squared minus 4 times a is 4 times c is negative 7 equals 0. And I will have to find what my k value should be. So I'm just going to isolate for this. So this is going to be k squared. Now negative 4 times negative 7 is 28, 56, 112. So positive 112 equals 0. And so bringing the positive 112 to the other side, this is going to be k squared equals, bringing that to the other side, negative 112. And taking the square root of both sides, I actually cannot do this. So, what does that mean? There is no value for k that will make this have one solution. Okay? But this was a bad example. You may have one where you actually find the k value that gives this one solution. So just be careful when it asks you stuff like this. You are finding the value of k where there's only one solution. That just means the discriminant is equal to 0. It may ask you to find the value of k where you have two solutions. So that's when this is greater than 0 and so forth. Okay? So you'll find some of these questions in your homework.